Hi, I'm Matt Redden, a technical sales specialist with the production software team at Hexagon, and welcome to this ESPRIT EDGE demo. Today we'll walk through creating a reusable template for the STAR SR20 RIV Swiss CNC machine. This template will make future setups faster and more consistent so you can start programming with just a few clicks. Let's get started. First, we'll download the machine files from ESPRIT Web. These include the machine project, machine GDML, controller GDML, post processors, and any associated fixture files. Once the download is complete, we need to place these files in the ESPRIT Edge data folder. The default file path is typically a C drive, users, public, public documents, Hexagon, ESPRIT Edge, data. Inside this folder, organize the files as follows. Machine files go into the machine folder. Posts into the post folder. Mounting blocks into the holder folder. Collets into the fixture folder. Keeping these files in the correct location ensures the ESPRIT Edge can automatically load your machine configuration and tooling when you start a new project. This step is critical for building a reliable template that works every time. With ESPRIT Edge open, start by creating a new default metric file. Next, go to Machine Setup and select the STAR SR20 RIV machine from your data folder. When the machine file loads, you'll see the options contained in the machine project. Let's take a quick look at these settings. The machine project defines the configuration for your machine. It includes general items that affect NC code output, work offset transformations, linking moves, and other machine-specific settings, among others. Once the machine project is loaded, click on Settings to add your post-processor files. We'll start with channel 1. Add the post and identify it by adding an _CH1. Then add the channel 2 post and label it with an _CH2. Adding the post separately allows ESPRIT Edge to generate split outputs for channel 1 and channel 2 when posting your finished program. While still in machine setup, highlight the STAR SR20 RIV machine and click the fixture icon. We'll start by adding the 20mm guide bushing GDML. When the file opens, make sure to select the correct adapter position. This machine has 3 named adapter positions. Choose guide bushing adapter, then click OK. Next, click the fixture icon again and select the 20mm collet. For this one, choose the main spindle adapter position. Finally, repeat the process for the subspindle. Select the subspindle adapter position and add sub to the collet name for easy identification. With these fixtures in place, our machine setup is ready for tooling. Next, we'll move into the Tool Assemblies tab. This tab contains all the predefined stations from our machine setup, including the main gang, B-axis, and back-facing tooling. The first tool we'll define is the cutoff tool in Station 1. Highlight Station 1, then go to the tooling ribbon and select the grooving icon. In the General tab, name the tool T100 Cutoff. Here, you can also adjust coolant code output and compensation controls if needed. Next, switch to the Shank tab. Update the shank size to 12mm by 12mm. Set the overall length and square up the shank offset to 12mm. Finally, go to the Insert tab. Select a 2mm insert width and size, adjust the length, and click OK. Our cutoff tool is now ready. Next, we'll add a 55-degree diamond turning insert to station number 2. Highlight station 2, then go to the tooling ribbon and select the turning icon. In the General tab, name the tool T200 55-degree turn. Now, switch to the Shank tab. Update the shank size to 12mm by 12mm. Set the overall length and square up the shank offset to 12mm. Finally, go to the Insert tab. Select the D diamond 55-degree shape, Leave the remaining inputs as a default and click OK. Our second tool is now ready. Now we'll add a 3mm full radius groove to station number 3. Highlight station 3, then go to the tooling ribbon and select the grooving icon. Click Default All to clear any settings from the previous tool. In the General tab, name the tool T300 3mm full radius groove and update the length register. Now, switch to the Shank tab. Set the shank size to 12mm by 12mm, adjust the overall length to 100mm, and square up the shank offset. Finally, go to the Insert tab. Change the insert shape from groove to full radius. Set the nose radius to 1.5mm, adjust the insert size, and click OK. Our full radius groove tool is now ready. Next, we'll add a 55-degree diamond back turning insert to station 4. Highlight station 4, then go to the tooling ribbon and select the turning icon. The inputs from our last 55-degree tool are already present, so we won't need to make many changes. In the General tab, name the tool T400 55-degree back turn and update the length register. Now, switch to the Shank tab. Set the shank size to 12mm by 12mm and change the hand of tool to left. The insert settings can remain the same as the previous tool, so click OK. Once the tool is defined, we need to adjust the default tool holder to position the tool correctly. Right-click on the holder above the tool, select Edit, rotate 180 degrees around Z, and click OK. Our back turning tool is now ready. Next, we'll add a 3mm full radius left-hand groove tool to station number 5. Highlight station 5, then go to the tooling ribbon and select the grooving icon. The inputs from our last grooving tool are already present, so we won't need to make many changes. In the General tab, name the tool T500 3mm full radius groove left hand and update the control edge to left. Now, switch to the Shank tab and change the hand of tool to left. For the Insert tab, we can use the same settings from the Station 3 groove tool since the inserts are identical. Finally, we need to adjust the default tool holder to position the tool correctly. Right-click on the tool holder above the tool, select Edit, rotate 180 degrees around Z, and click OK. Our left-hand full radius groove tool is now ready. Next, we'll add a 3mm drill to station 7. Highlight station 7, then go to the tooling ribbon and select the drill icon. In the General tab, name the tool T700 3mm drill. Now, switch to the Extension tab. Set the extension diameter to 0 and update the overall and tool lengths to 30mm. Move to the Shank tab and leave those inputs as the defaults. Finally, go to the Cutter tab, update the tool diameter to 3mm, set the cutting length to 20mm, and click OK. Our 3mm drill is complete. Next, we'll pivot to the B-axis unit and add a 6mm end mill to station 17. Highlight station 17, then go to the tooling ribbon and select the end mill icon. In the General tab, name the tool T17 6mm end mill and update the length register. Now, switch to the Extension tab. Set the extension diameter to 0 and update the overall and tool lengths to 30mm. Finally, go to the Cutter tab. Update the tool diameter to 6mm, set the cutting length to 20mm, and click OK. Our 6mm end mill is ready to go. Next, we'll add a 10mm spot drill to station 18. Highlight station 18, then go to the tooling ribbon and select the drill icon. The inputs from our previous drill are still present, so we won't need to make many changes. In the General tab, name the tool to 10mm spot drill. Now, move to the Cutter tab. Update the tool diameter to 10mm, set the tip angle to 90 degrees, and click OK. Our spot drill is now ready to go. For the backside of the B-axis unit, we'll add a drill to station 19. Highlight station 19, then go to the tooling ribbon and select the drill icon. Click Default All to clear any previous inputs. In the General tab, name the tool Drill 10mm B-axis back and update the length register. Now, go to the Extension tab. Set the extension diameter to 0 and update the overall and tool lengths to 40 millimeters. Finally, move to the Cutter tab. The default diameter is already 10 millimeters, so we can go ahead and click OK. Our backside drill is now ready to roll. Next, we'll pivot to Station 31 to add a mounting block. Mounting blocks allow users to configure stations using machine components that can be swapped in and out on a Swiss CNC machine. Highlight Station 31, right-click, and select Add Mounting Block. From the Holder folder, choose the Front 2 Spindle Unit GDML file and click Open. You'll see the spindle unit mounted to Station 31. Click OK to confirm. This mounting block adds 2 additional stations, which you can see in the Tool Assemblies tab. Now, let's define a tool for Station 3112. Highlight Station 3112, go to the Tooling ribbon, and select Drill. In the General tab, name the tool 5mm front face drill and update the length register. Next, go to the Extension tab. Set the extension diameter to 0 and update the overall and tool lengths to 40 millimeters. Finally, move to the Cutter tab. Set the tool diameter to 5 millimeters, adjust the tip angle to 135 degrees, and click OK. We've successfully added a mounting block with a front-facing tool. We've successfully added all of our front side tooling. Now it's time to move on to the back gang. We'll start by adding an OD turning tool to Station 21. Highlight Station 21, go to the Tooling ribbon, and select Turning. Click Default All to start from scratch. In the General tab, name the tool OD Turn Sub. Next, move to the Shank tab. Change the shank type to round shank, set the tool diameter to 16 millimeters, adjust the overall length to 50 millimeters, and set the shank length to 40 millimeters. Now, go to the Insert tab. Update the insert shape to D-diamond 55 degree. Set the inscribed circle diameter to 8 millimeters and the thickness to 3 millimeters. Finally, toggle back to the Shank tab to make 2 final changes. Update the lead angle to -5 degrees and set the center offset to 12 millimeters. Click OK, and our OD turn tool is now complete. The last tool we'll add to our template is the 10 millimeter sub-facing drill in Station 22. Highlight Station 22, then go to the Tooling ribbon and select Drill. In the General tab, name the tool 10 millimeter drill sub. Next, move to the Extension tab. Set the extension diameter to 20 millimeters. Update the overall length to 60 millimeters and set the cutting length to 40 millimeters. Finally, go to the Cutter tab. Update the tip angle to 135 degrees and click OK. Our 10 millimeter sub drill is complete, and we successfully created all the tools needed for our Star SR20 RIV template. With our machine, fixtures, and tooling all set up, we're ready to save this as a template. Go to File, select Save As, and navigate to the template folder inside the ESPRIT EDGE data directory. Name the file Star SR20 RIV template. We can save this as a standard ESPRIT file. No special format is needed since all the components are already stored in their respective data folders. Once saved, the template is ready to use. When you open ESPRIT again, simply go to My Templates, double-click to open, and you'll see the complete machine setup, fixtures, and tooling recreated, so you're not starting from scratch every time. At this point, ESPRIT EDGE is truly plug and play. Once our template is open, go to File, select Insert, and choose your CAD model. Next, go to Part Setup. Select the CAD as the part to cut and click OK. We'll add stock from bar by selecting bar from the ribbon, define the stock dimensions, and click OK. With the part and stock defined, head to the machine setup to apply the workpiece. We are now ready for programming. Having an accurate digital twin of your machine combined with a reusable template saves significant time on future jobs. It ensures consistency, reduces setup errors, and allows you to focus on programming rather than repetitive configuration steps. With this workflow, programming Swiss parts becomes faster, more reliable, and scalable for your shop. Thanks for following along as we built a reusable template for the Star SR20 RIV in ESPRIT EDGE. If you found this helpful, be sure to like, comment, subscribe, and check out more ESPRIT EDGE tutorials for advanced Swiss machining workflows. Thanks for watching, and we'll see you in the next video.